Here's a problem you can't have an idea about, at least at first. I should say you can't. You might be able to. Let's shut this down. How many times do you have to flip a coin? I'm going to put two words on here that are going to make this possible. On average. Until you see each side at least once. You guys be so kind? Got a bag of pennies? Grab one, hand the bag around. I want you to think about the answer to this question. This goes in, Kirsten, by the way, to the Lego problem you were asking about in the homework. This is tied to that. If they were coins. We'll talk about why they are, basically, in a second. So here's a question I have for us today. I have two questions left for today. Here's the first. If you have a coin, and you're flipping the coin, catching it, putting it on your hand, you're going to get heads or tails. Heads or tails. What I want to know is, how many times, on average, do you have to flip that coin until you see each of the sides at least one time?
3 or 4.
Okay? I hear 3 or 4.
4 and a half.
4 and a half.
I think 3 and a half.
3 and a half. So we got, I heard 3, 3 and a half, 4, 4 and a half. How many say 3? 3? We got 1, 2, we got 2, 3. 3 that say 3. Anybody say 3 and a half? Oh, Joe, did you say a 3 as well? You said 3 as well. 2. Okay, on average, 2, because you're going to get 1 the first time and 1 the other time on average. Like that. Very nice, thank you. So 3, we got 2. Let's go through it. Who says 2? We got 1, at least 1 vote for 2. 2, 3, 4, 5, 6. 6 say 2. Who says 3? We have 4 3s, I believe. We have 4 3s, yeah. 3 and a half? 3 and a half?
That's my guess.
3, 4. Good, 4. Who says 4? It's going to take 4. 2, 3, 4, 5, 6. Okay. How about 4 and a half? We have at least 1 vote for 4 and a half, I thought. Maybe I heard that. I'm envisioning things. 4. No, it's just 4. Okay. Anybody say more?
I just guessed 4.
Oh, you just get that? That's all you can do, right? 5. And this is Sherry. Shelly Sherry. That's right. That's right. Okay, so we got 5. Love it. Now here's the beauty of this. Every one of those guesses is damn close to the true average. You can calculate it mathematically, but I don't want to calculate it mathematically. I'll show you the calculation mathematically momentarily. What I want us to do is to do a different kind of estimation, which is estimation through experimentation. So here's what I want you guys to do. Start flipping and count how many times it takes you until you see each side once. So for example, if you flip and get heads, then flip again and get heads, then flip again and get tails, it took you 3 flips to see each side at least once. If it goes heads, tails, that's 2. If it goes heads, 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 tails, that's 6. You see what I'm getting at? So keep flipping. Do it, let's each do it 5 times. In other words, flip each 5 sets until you get each one at least 1 time. Make sense? You guys see what I'm getting at here, friends? And we'll collect our data, and we'll put it together, and we'll take a look. Yes.